Hey there, fellow explorers of the unknown. Welcome back to Dr. Answer and Nosy. Today, we've got a question that's as blue as the sky itself. Why is the sky blue? And of course, our trusty guide through the mysteries of science, Dr. Answer, is here to shed some light on it.
Thank you, Nosy. Hello, everyone. I'm Dr. Answer, and I'm ready to dive into this colorful question with you.
Dr. Answer, I've always wondered, why is the sky so blue? It's like a never-ending ocean up there.
Well, Nosy, the blue color of the sky is due to a phenomenon called Rayleigh scattering. You see, sunlight is made up of various colors, each with different wavelengths. Blue light, which has shorter wavelengths, is scattered more by the molecules and particles in Earth's atmosphere.
So, it's like trying to catch a handful of marbles thrown in all directions. The blue ones go bouncing everywhere.
Exactly, Nosy. The blue light gets scattered in all directions, including down toward us, making the sky appear blue.
Ah, so that's why the sky is blue. But what about sunsets, Dr. Answer? Why do they turn all those lovely shades of orange, pink, and red?
Sunsets are a beautiful phenomenon. During a sunset, the sun is lower on the horizon, and its light has to pass through more of the Earth's atmosphere. This means that the shorter blue and green wavelengths scatter even more, leaving the longer red and orange wavelengths to dominate the sky.
So, it's like the sun is a cosmic artist, painting the sky with its own palette during a sunset.
That's a poetic way to put it, Nosy.
Alright, Dr. Answer, if the sky is always blue during the day, why do we sometimes see it as gray or even orange during certain weather conditions?
Good question, Nosy. The appearance of the sky can change based on various factors. For instance, when there are a lot of water droplets or ice crystals in the atmosphere, they can scatter sunlight differently, creating gray or overcast conditions.
So, it's like the sky is playing dress up, putting on its gray or orange outfits depending on its mood.
You could say that, Nosy. Weather and atmospheric conditions can indeed make the sky don different colors.
Speaking of blue, the ocean is blue too. Is there a connection between the blue sky and the blue sea?
Absolutely, Nosy. The blue color of the ocean is also a result of sunlight. Water absorbs colors in the red part of the light spectrum and reflects blue and green wavelengths. So, when sunlight hits the water, it's those blue and green wavelengths that bounce back to our eyes, making the ocean appear blue.
So, it's like the sky and the ocean are in cahoots, sharing their blue secrets.
In a way, they are, Nosy. Nature has its own way of creating stunning color palettes.
Alright, Dr. Answer, let's switch gears a bit. Why does the moon sometimes look blue too? Is it related to the sky's blue color?
The blue moon phenomenon. It's not actually about the moon turning blue, but rather a rare event when it appears blue-gray in color. This can happen when there are particles, like dust or smoke, in the Earth's atmosphere that scatter shorter wavelengths of light, such as blue and violet. This scattering can make the moon look blue.
So, it's like the moon is putting on a disguise, trying to fit in with the cool blue crowd.
That's one way to think about it, Nosy. But remember, it's not a common occurrence.
I've heard about something called the blue hour. Can you tell us what that is and why it's called that?
Of course, Nosy. The blue hour is a period of twilight, typically before sunrise or after sunset, when the sun is just below the horizon. During this time, the indirect sunlight creates a beautiful soft blue hue in the sky. It's called the blue hour because of the distinctive blue color that dominates the scene.
So, it's like the sky is having its own little fashion show, featuring different shades of blue during the day and during twilight.
That's a creative way to put it, Nosy.
Well, there you have it, folks. The sky's beautiful blue color is all thanks to Rayleigh scattering, where shorter blue wavelengths are scattered more by the molecules and particles in our atmosphere. And when it comes to sunsets, sunrises, and even the moon's occasional bluish appearance, there are fascinating scientific reasons behind them all.
That's right, Nosy. And if you enjoyed this podcast episode, don't forget to hit that like button, subscribe, and share it with your fellow curious minds. Stay tuned for more colorful questions and their brilliant answers on Dr. Answer and Nosy.
Until next time, may your skies be blue, your questions be colorful, and your curiosity as boundless as the universe. Bye, everyone.